Okay, welcome to our final capstone video. We are the Genomics Disease Manager team, and we wanted to be able to assist doctors in making a genetic diagnosis. I am Matthew Johnson. I worked as a team lead, and we'll go ahead and introduce the rest of our team members.
Hi, my name is Jesse Jenkins. I worked on the hosting and the genetic algorithm.
My name is Jesse Johnson. I helped with the coding on our front end and the back end, and I also built out our AI system.
Hey, and I'm Cynthia Lancaster. I was our main front-end developer. I also worked with our geneticists throughout the semester to get user feedback on our system.
So let's quickly go over the problem that patients and doctors are faced with. A lot of times a genetic patient, as they come into a doctor, they're not able to get a timely diagnosis or even an accurate diagnosis because most doctors are not genetic specialists. And when they face symptoms that could be a genetic disease, they might not even recognize that this is a genetic disease. So a lot of times then this patient can just go undiagnosed for years. And this is because only 1 or 2% of clinicians are even geneticists in the first place. And these guidelines to diagnose somebody with a genetic disease are not very well known. So the users of our software are going to be clinicians, doctors, and any trained specialist that is inputting any patient data into an EHR. And as a user, I want to be able to give the highest quality of care to my patients as possible. And in order to achieve this goal, then we would have to be able to diagnose a genetic disease as quickly as possible and as early as possible in order to get our patient the best care that they can get. So our solution to this problem is to alert a doctor as soon as our algorithm might detect that this patient could have a genetic disease. And once we have alerted a doctor, we want to give them a page that they can go to look at as much information on that disease as possible and any relevant information from this patient's any lab results they have or any data that they might have that could be relevant to this genetic disease. And we also want to give this doctor a really easy pathway to refer this patient to a genetic specialist. Because a lot of times, even though this doctor may have the information about this genetic disease, they're still not a specialist. So from a user perspective, you would have a doctor going about their day-to-day business in an EHR system, and they'll have a little tiny notification at the bottom or on the sidebar that will tell them that this patient could be a genetic diagnosis. And if they click on that notification, they'll get lots of more information about that specific disease and how they could potentially benefit their patient.
So let's just jump right into our demo. So first you have to start by entering our patient's name, and for this we're going to use David Hughes. And after selecting our patient, we're brought to the chart review page. And we can see there's a lot of data here. Most of this is being pulled from our database, and it's dynamic data that we are able to pull from the HL7 database that we have. And this whole entire application is built to mimic the EHRs that doctors use on a daily basis. So we kind of reinvented the wheel on a lot of this stuff, but we built it this way so that we could have a doctor look at it and kind of understand without having to relearn how to use an EHR, or our EHR in particular. And so there's all these tabs up at the top. One of the key behaviors that we wanted was to be able to add an observation. So if we go ahead and add an observation here, let's add that observation, and then we go over to the history tab. This is the observation that we just barely created. And so you'll see there's so far David has 4 observations on his list, and this one here was actually created in response to this observation. So what happens is we have an AI algorithm that goes through and reads all of the observations and the notes that are attached to those observations, and it will make a predicted diagnosis. And so you can see this one says predicted diagnosis, Alport with 61% confidence. That is our AI saying that it's 61% confident that whatever notes the doctors typed in are indicative of a genetic disease called Alport syndrome. So when the patient is flagged by our algorithm for a genetic disease, this will turn orange, and the doctor can hover over it to see suggested diagnosis, Alport syndrome. So that was what our patient was flagged for. There's a number of things you can do here. You can add it to the problem list, and each of these will do a different behavior that we will go into in a little bit. Or we can launch the disease manager. From there, the doctor will go to the genetics page, and that's what our genetic disease manager page is. And there's a lot of things you can see here. As you can see, there's medical genetics. We can prescribe medication for the Alport syndrome, the disease that the patient was flagged for. And just additional information, we can look at the info button to see some more information. There's like these different care options for the patient, as well as some articles, some up-to-date articles that are relevant for the disease. So we can actually also upload genetic data to the patient. And so I'm going to upload some data to David's file. And this file here, this JSON, was actually created from the patient's genetic data. If we go ahead and upload that, file uploaded successfully. Nice. So if we go over to the history section, we'll actually see all of these new observations that were created. So each of these were created and tied to something called a diagnostic report. You can see each of these has their own code, their own label, and they all have different meanings within the patient's genetic information. So if we go over to some of these other tabs, a lot of these we kind of just reinvented the wheel as we made them. The allergies page, the patient was, or this pulls the allergies. This patient doesn't have any problem list. There was actually a lot that went into these because we had to make sure that each of our API calls to and from our database were HL7 compliant and HIPAA compliant. And so all of these, so we can add medication for the patient, we can add problems to their problem list. And this isn't a comprehensive list of all of the problems that you could add to your patient, but these are kind of some things that we needed to have and also some common things that doctors use on a daily basis. You can also prescribe medications, same deal here. And I think that's just about it for the usability of our project. So we'll go into some of our technologies next.
Okay, so the technologies that we ended up using to accomplish this project. So we used a Node.js backend with a React frontend, and we had to use a FHIR server with HL7 data standards because that's the industry standard. That's how we transfer our data and to and from our database. And we used a Jenkins server to deploy our backend and frontend, and we used AWS to host all three of our services and our Python service as well. So over the course of our project, we started our development in September of last year, and we've had 132 issues opened with 102 issues closed. So obviously we're still working on the project, and we still have future plans for how this project will be accomplished. And we have 245 individual pushes by all 4 of our developers and 18 separate HL7 calls to our FHIR server. These are a few of the libraries that we ended up using for our AI service. We also ended up using a service to translate some of the genetic data into the JSON. So for our user studies, we were actually able to get in contact with 5 practicing geneticists that were in the field, and because we were working with a PhD student, he was able to get funding to pay these geneticists to go over our software. Some of the valuable information they gave us was they didn't want any pop-ups or any notifications that would interrupt their workflow. So that's why we ended up going with just that highlighted area on the sidebar, as you saw in our demonstration. They also gave us some really useful advice on when we should run our algorithm. They also gave us some advice on adding some info buttons into our genetic disease manager page. These are an industry standard, and so just having those info buttons in place for like the genetic disease information was really useful for us.
In summary, the core issue we're addressing is that patients with genetic conditions are often left without timely or accurate diagnosis. The guidelines for genetic diagnosis aren't widely known, and so as a result, patients are passed from one provider to another without clear answers. Our solution is designed to change that. By implementing a smart algorithm that can flag potential genetic patients early in their care journey, we can alert the clinicians when a genetic condition might be involved. With this approach, we're not just improving care, we're also empowering clinicians and delivering better outcomes for their patients.